Hi everyone, this is Chauke speaking, a facilitator of building and structural construction in 5 at Majibat College. We are continuing with video part 1D, but in this video you must understand that we are done with the problem that we're dealing with in video 1A, B, C. So if you have not watched those ones, please go and watch them. But in this video I want to demonstrate what I call semi-analytical and semi-graphical method of the same problem that we're doing. All right, what I mean is that it may happen that in the exam you are not all right, the problem that we're dealing with is this one, remember? Okay, we're dealing with this problem. So it may happen that in the exam they did not specify which method you're supposed to use, meaning that they are not strict. You can choose whichever method, either graphical or analytical method. So in that case, you can start by calculating reactions analytically. So let's say you have calculated your reactions analytically here, which maybe we'll do or I'll demonstrate in another video. But let's say you've calculated reactions RL and RR analytically. Now you can use the very same reactions and also the external forces to draw or to determine the members using graphical method. So you are combining the analytical method and the graphical method. So that's what I want to demonstrate at this point in time. Now the first thing that you need to do is determine this angle between this force and the horizontal. Also, you won't be given, or you may not be given, this angle actually. So how do you work it out? This angle is 30 degrees, right? And the angle here is 30 degrees, which because they are alternating. Again, this force 5 kilonewtons is perpendicular to this member, meaning that it's forming this 90 degrees. So if we've got 90 degrees here, and yet this is 30 degrees, it means that the angle between the horizontal and that 5 kilonewtons is 60 degrees. So that's the angle that we are interested in. Now that we have this angle, which is the same as this angle here for 10 kilonewtons, is also acting at an angle of 60 degrees. Now you can choose a stable scale. I have plenty of space here, so I can use 1:1, no problem. So I'm gonna start with AB going in the clockwise direction. All right, so I'm gonna say, okay, the first thing that you need to do, maybe just draw a small Cartesian plane for yourself. A small Cartesian plane for yourself. All right, now that you have your Cartesian plane, you'll come here and measure the angle of 60 degrees from the horizontal. All right, from the horizontal, you can see that AB is going down, but at an angle of 60 degrees. So we're gonna come here. Sorry. Okay, and that is 5 kilonewtons. I'm gonna use 5 kilonewtons at an angle of 60 degrees. If you can see there, hit enter, and then that is my AB, right? And then BC is 8 kilonewtons going down vertically. So 8 kilonewtons going down vertically, that is force BC, or force 8 kilonewtons. So I'm gonna say 8 kilonewtons, enter, and then CD is 10 kilonewtons acting at an angle of 60 degrees. Remember, 60 degrees, 10 kilonewtons, and then DE, force DE, which is 12 kilonewtons, is acting at an it's acting vertical. So I'm gonna say 12 going down, and I'm also going to say 5 going down again. So okay, before I continue, let me say copy here, this one yeah. I have A, that's my 5 kilonewtons, AB, then this is my 8 kilonewtons, BC, okay, no. As BC is fine, and then CD is that one for 10 kilonewtons, that's my D, and then DE is the 12 kilonewtons going down, it's E, and I have EF, which is 5 kilonewtons, EF, which is 5 kilonewtons, let's say 5. All right, I would say 5 kilonewtons. Yeah, here we go. This is F, right? Okay, let me move all of this. Okay, all right. Okay, now that I have that one down, you must remember that RR now is FG, which is acting at an angle of 69 degrees and is 20.7. So I'm gonna come here, I'm gonna say I want 20 0.776 at an angle of 69. Hit enter. No. All right, I have to work it out, but just so that I do it quickly, I will just come to this one here, RR, which is from here. That one I need to work it out because my CAD is measuring from in an anti-clockwise direction. So just to save time, let me just do it from the RL, which is 18, which is because it's vertical, it's gonna be easy that way. 18.63, and then I hit enter. You see, so this one is straight, and then I'm just gonna come here and close it. So this is my come here. This will be G. All right, this will be G. If you want to check, let's check the distance here. You can also check what can you see. The distance is 20.7, so it ties up nicely, 20.7, and the angle is 180 minus 111, which is 69. Okay, or I can just do it like this. You can check even the angle. The angle here is, can you see, 69. So it is tying up nicely there. All right, so that's what I was talking about. Remember, this one we did it graphically, but here I'm assuming that we have calculated this one analytically, and then this is how you go about it. All right, so there's no need for dealing with the resultant here. You can just take your forces just like they are. Okay, so I'm gonna do the members very quickly. Okay, if you did not watch B of the video, please do so. But I'm gonna start with this joint here. I'm gonna take it to A. Okay, I'm gonna take it to A. I'm gonna take it to A. I'm gonna take it to A. Okay, and then G. G is horizontal. I'm gonna take G here, horizontal. This one you measure it with 30 degrees from the horizontal line. Horizontal line you measure 30 degrees. So I'm gonna copy this one here, G, which is my horizontal line, and then I'm gonna extend this one. All right. I don't need this. Okay, now I will go to this joint. This joint I've got CJ and HG. CJ is inclined as well. CJ at an angle of 30 degrees. I can just come and go there, measure an angle of 30 degrees at C. Okay, let me change these ones here to be another color so that you may see what the members are. All right, let's change them to red. All right. These are external forces. Okay, very quickly. I have C, J. All right, so I'm gonna take this one here. Where they meet, I have where they meet, I have what? I've got H. So this is your H. All right, and then I've got this one now. I do have H, so I must can take it from here. Do have H. Let me do something here. Let me just extend this. Okay. All right, so where they meet, I've got where they meet, I have where they meet, I have J. So I've got J here very quickly. All right, I'm done with that joint. I'll come to this joint, whereby this one is vertical. I'm coming to this joint, which is vertical. Come here very quickly. I'll come here, and then there is EK. So EK, I'm gonna copy this one. I do have E there. Okay, I do have E. I'm gonna extend this one. E. All right. So where they meet, I have my K. My K there. Now I can come to this joint here. All right, I'm left with L. I'm gonna copy this one. I do have K. I'm gonna come here. K there. I'm gonna remove this one here. Where it meets G, that's where I have a joint. That's where I have that's why I have L. Right, I'm done with this joint. And then the one last member that is left is LF. So I can just come here. There we go. So this is how you combine the analytical and the graphical method. Okay, so I did this part very quick. If you need to not get it, just go and watch I think it's video number 1B. That's when I demonstrated how to do this slowed. All right, so that's about it. Thank you very much.